Okay, so in the first example, they want you to give an example of exponential growth, exponential decay, and neither. So let me give some examples. That would be exponential growth because this is greater than 100%. Make that a little bit closer. It's actually increasing by 7% each month, each year. Here's an example of exponential decay. This one is actually decreasing by 7% because it started at 100%. But if you look, in both cases, I want you to see what you start with has no relevance to the growth or decay. This is what you start with. I start with $3. I start with 3 bunnies, okay? An example that would be neither, there's a couple. It could be this, because this doesn't grow or decay. It's at 100%, so it stays the same size. Another example could be this, because the base is X. It could have growth or it could have decay. So again, I want you to be aware that the growth is based on the base. It's all based on the base. Okay? All right. So this time we start with 2567 and we lose 7%. So if you look, and I would like some of you to be here, or you can just go straight to doing that, okay? And it said function, so actually, I'm sorry, I should be rewriting it as f of x equals 2567.93 to the x. Okay? All I want you to do is write this in logarithmic form. So if you're going to write it in logarithmic form, the first thing you have to do is write the log. Base x, 6, equals 12. Now, if you're feeling like you don't know if it's good, play the same game here. X to the 12th equals 6. That matches your good. Make sure all of these are the exact same size, and then that's a subscript. I'm going to be picky about that. This one, I need to convert it to exponential form. So I play the same game. 7 to the negative 3 equals 1 over 343. And if I'm not sure if that's correct, well, when I take 7 to the negative 3rd in my calculator, let me actually grab a calculator and show you. So in my calculator, if I go 7 to the negative 3, make sure you go negative 3, not minus 3, it tells me 0.002529, whatever. And then if I go second PRB, it changes it to a fraction, and boom, that's 1 over 343, which matches that. So I'm good to go. All right, now I want to evaluate this. It's going straight to the hard stuff. So log 7, this has to be a 7. So how can I manipulate that? Let me make that a little bit closer. I know it's going to be 1 over 7 to the something. So let's do some guess and check. 7 squared. No. 7 to the 3rd. Yep. So that means it's 1 over 7 cubed. But that has to be the 7 on top, so it's really 7 to the negative 3. The little turns big. That turns into 1. Boom. Your answer is negative 3. Notice I have no equal sign. There's no equal sign in the problem. There should be no equal sign in the answer. Next one, simplify. Well, the problem is I can't change the 17 to have an 8. That doesn't work. So the rule is the log of the answer, or the log of the big, over the log of the base. So now I'm going to pick up my calculator, and I'm going to go log of 17, end your parenthesis, divided by log 8. You don't have to end your parenthesis. And when you see, think of money. So it's $1.36. The 2 doesn't have you round. But technically, you're rounding to the nearest hundredth. Like there's 100 cents in a dollar. Okay? This one, the rule states that when you're adding, it really means multiply, and you need to show that work. Everything I'm showing you is what you need to show me. They need to have the same base. Little turns big, and I get 3. I want to point out, I could have done this a different way. So let me get a piece of paper here so you can see it. I could have done log 2 to the 0, which is this, plus log 2 cubed. Little turns big. Little turns big. And 0 plus 3 is 3. I don't care if you do it this way or this way, get 3. Okay? Log 3, 819, divided by 99. Use your calculator. 81. Make sure the bases are the same. If you don't know what it is, use your calculator. 3 cubed, no. 3 to the 4th, yes. Little turns big, that turns 1, and now we're at 4. Okay, let's continue. If I don't have a base, there's an imaginary base 10. So that means I need to go log 10, 10. So now I've got to focus on this. I don't know about you, but I get kind of, it's difficult for me to go, is it hundreds, thousands, 10,000? So just count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I moved it 5 times, but it's in a fraction form, so that's to the negative 5. Little turns big, and I'm good to go. Okay. Let's go to the next one. In this one, we have an exponent. You're not going to keep it because you can't calculate 81 to the 4th. So the little turns big. And I'll just leave that there so far. Now, I can't change the 1/3. The 1/3 is my base. The base means it's decay. It's less than 1. That means this has to be a 1/3. Okay? So let me pause this real quick. I know that 81 is the same thing as 3 to the 4th, but it needs to be 1 over, which means it's to the negative 4th. Whole number to a fraction is going to be negative. Now, this little turns big. That's 1, and that's negative 16. Okay, let's go to the next one. Same game. Little turns big, but this needs to be in parentheses. Boom, times 1. And then based on the distributive property, the answer is 9 minus x. If you skip this step and don't show me that you're using the distributive property, you're just memorizing something. Okay, let's go to the next page. All right, the goal here is to make the bases the same. Well, the thing about the 16 and the 64 is I could use 4 or I could use 2. It doesn't matter. I'll use 4 because I feel like it. 16 is the same thing as 4 squared, then it's times 5x. 64 is the same thing as 4 cubed times x plus 7. Now, now that the bases are the same, boom, set those equal to each other. Make sure you're distributing. Make sure you distribute to both. Small x to big X, and then x equals 3. And then if you have time, you'll check it and see that it's going to work. Okay? Let's look at this one. I want to play the same game, but the problem is I can't change a 12 to a 2. So what do I have to do? I have to log both sides. Now, when I log both sides, this is a pretty complex one, so we're going to have to go slowly on this, because not only is there a little on this side, but there's a little on this side. So I'm going to have to rewrite it as x plus 1 parentheses log 2 equals 3x parentheses log 12. Okay? So the problem is, in this case, I have logs on both sides. So what I'm going to do is I'm going to move this log over here, and then I'm going to move this over here to get the x's together. So I'm going to divide by log 2. Okay? And then I'm going to divide by 3x. And then I'm going to be left with x plus 1 over 3x equals log 12 over log 2, whatever that is. Okay? And you know what? Actually, I'm going to probably need more paper for that. So I'm going to go log 12, and then I'm going to go divided by log 2. Oops, I did natural log. Log 12 divided by log 2, and I get 358, which you can't see very well. So let me rewrite this, and I'm actually going to get more paper for this. So this turns into x plus 1 over 3x equals 358. So all I did was divide that. Now the problem is I have 2 x's, and this will be a pain if I leave it like this. So now I'm going to take the 3x and I'm going to move it back. And really what I'm seeing is maybe I shouldn't have moved it up here in the first place. So if I wouldn't have moved it in the first place, this is what I would have gotten. By doing that, I get x plus 1 equals. Now I have to distribute. So I'm going to take my 358 that's in there and multiply it by 9, and I get 3226. Wait a minute, something happened here. 3.58 times 3, I think I might have done an exponent. And I get 1074. Now I'm almost done. I just need to subtract 1. So x equals 974. Okay, let's go to the next one. All right, in this problem right here, my issue is the little needs to turn big. So I'm going to make this big. Now this is in log form. I want to change it to exponential form, but I can't do it with a 6 there. 6 is being multiplied, divide it. Now it's a single log, there's nothing on the outside. Now, boom, change it to exponential form. 3 squared equals x, x equals 9. So this problem has 2 logs, and this one only has 1. So we're going to make 2 logs be 1 log, and then we'll change it to exponential form. The rule for when you're subtracting is that you divide. Now it's a single log, I can change it to exponential form. But the problem is there is no base there. So I create a base, base 10. Now boom, change it to exponential form. 10 to the first equals x over x plus 9. 10 to the first is just 10. We solve by multiplying both sides by x plus 9. That's gone. X equals distribute, distribute. Move this x over here by subtracting 10x, imaginary 1. I'm left with 90 equals negative 9x. And move that over. Divide by negative 9. X equals negative 10. Okay? Now, I have to be careful because I got a negative answer, and that's usually when there are limitations. If I took the log of negative 10 in my calculator, which I'll show you right now, the log of negative 10, it tells me I can't do it. So it's actually, there is no solution. So always check your work. Okay. Let's go to the next one. Okay, we've got a whole bunch of logs happening here, but I see 1 log on this side and 2 of them on this side. So I'm going to take these 2 and combine it and make it 1. And remember the rule states, when you're adding, it means multiply. So I'm going 6 minus 3x times 2, backwards distribution, log of 12 minus 6x equals log of x minus 8. Remember when they have the same base and they're set equal to each other, you can just focus on this part. And that's exactly what I'm going to do. X minus 8 equals 12 minus 6x. Add 6x. Add 8. X equals 20 over 7. And we gosh darn hope it works because that seems like an annoying one to check. Okay. Now, in this one you need to compare them. So you need to show equality or inequality or compare the bases or simplify to some degree. So I'm just going to look at the left side, make the little big, change the base, make the little big. So this side is 6. So now that I simplified the left side, I'm going to simplify the right side. They have the same base, so when I add, it really means multiply. 81 times 3 in my calculator is 243. Make the bases the same. 3 to the 5th. Little turns big. 5 times 1 is 5. I can see that 6 is bigger than 5, so I'm good to go. All right, next one. What I'm going to do here is I'm going to plug in these values. Fine, use your darn calculator. I'm okay with it. But I know that anything to the 0 power is 1 times 17 is 17. So now in this case, I'm just going to go 0.92 to the first power, which I know is that, times 17, 1564. Remember, round to the nearest hundredth. Then I'm going to go 0.92 squared times 17, round to the nearest hundredth, 1439. Then I will take 0.92 to the negative 1 times 17. Oops, shoot, I got to do that again, sorry. Times 17, 1848. And then 0.92 to the negative 2 times 17, to 28.